Welcome to Maths Guru Educational Services. If you are studying with us on Maths Guru Educational channel for the first time, kindly click on the subscribe button so you'll be informed anytime we upload a new video on this platform. This session is dedicated to those offering educational administration and planning at the National Open University of Nigeria, Edu821 Statistical Method 1. We are going to discuss the Unit 7, which is Measures of Central Tendency. Measures of Central Tendency. Please, if you have not subscribed, do that before you continue with us. As is seen here, the measures of central tendency or location are a set of benchmarks or typical scores which make precise and brief presentation or description of a set of data. There are basically three measures of central tendency which are of interest to the statisticians. They are the mean, the median, and the mode. This unit will therefore expose you to the methods of handling or calculating them. So these are the targets: how to calculate the mean, how to calculate the median, and how to calculate the mode. As it's seen here, the question requires that we calculate the range, the mean, mode, median, variance, and standard deviation. For variance and standard deviation, please, we shall post the video very soon in our next section. Please keep on watching and then get yourself along as we try our best to put things in order. Now we have the first aspect, that is the mean. The mean, which is also called the average of a distribution, is obtained by dividing the sum of the scores of a distribution by the total number of scores. The mean is also called the average, and from our previous classes we learned that the mean is often represented by the sign here, X bar. So anytime we have the scores which are given as X, then the mean is given as X bar. If the score is represented by Y, for instance, then the mean will be equal to Y bar. Take note of that. So we are required to calculate the mean, and the mean is simply given as the sum of the data of the distribution, the sum of the scores of the distribution, that is summation of X over the total number of the scores, that is F or N if you like, the total number of the score. So we can give the mean as summation X over N, where N is the total number of scores in that distribution. So take note of this formula. You note that you can also give the mean as summation X over F, where F refers to the frequency of the distribution, which is also the total number of scores in that distribution. So don't be confused if you see something like this in another text. Now, for the first question, we're going to resolve that together. We have number 1. We are given 5, 12, 6, 8, 5, 6, 7, 5, 12, and 14. All we need to do to calculate the mean is mean equal to summation X over N. And we already know that the number of the scores we have here, is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have n is equal to 10 here. So now we are going to sum the whole scores there. 5 plus 12 plus 6 plus 8 plus 5 plus 6 plus 7 plus 5 plus 12 and plus 14 over the number of scores, that is 10. If we add all these numbers, we are going to have 80 over 10. And 80 over 10 is equal to 8. So we simply have 0 out and we are left with 8 over 1, which is 8. So the mean is equal to 8 for this first question. The mean is equal to 8. Now let's calculate the mean for this second question, number 2. The same way, the mean will be equal to the sum of the scores we have there. 3 plus 8 plus 10 plus 6 plus 7 plus 6 plus 9 over, we count the number of scores there, 1, 2, 3, 4, 5, 6, 7. So we have 7 altogether. If we add all these numbers, we're going to have 49 over 7. And 49 over 7 is 7. Therefore, the mean for this second question is equal to 7. Now let's calculate the mean for the third question there. The mean will be equal to the number of scores there. We have 4, 8, 10, 6, 7, 6, 8, 6, 8. So we add them up. 4 plus 8 plus 10 plus 6 plus 7 plus 6 plus 8 plus 6 plus 8. And we divide it by the number of scores there. 1, 2, 3, 4, 5, 6, 7, 8, 9. We divide it by 9. So the mean will be equal to 4 plus 8. We have 12 plus 10. We have 22. If we add everything, we're going to have 63. 63. So it will be 63 over 9. And 63 over 9 is simply 7. Therefore, the mean of this last question, that is question number 3, is also 7. So anytime, any day, we have this kind of question, the mean should be calculated this way. Now, let's talk about the median. The median is the middle score obtained when the scores are arranged in ascending order or descending order of magnitude. So take note of this. The scores in the distribution must either be arranged in ascending order or descending order of magnitude. So you have to first of all arrange the scores. So for number 1 question, this is what we do. We have to arrange the scores here either in ascending order. For this class, we're going to do it in ascending order. So we have the lowest, that is 5. We have another 5. We have another 5, 3 of them. Okay. Then we have 6. We have 6 again. Yes, we have 7, and we don't have any other 7. We have 8, right? Okay, we have 12, another 12, and we have 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, they're complete. So in this case, we eliminate from the beginning and the end one by one. Let's see what we're going to have at the middle. 1, 1, 1, 1, 1, 1, 1, 1. Oh, all right. We notice that 2 different scores appear at the middle. 2 different scores appear at the middle. In this case, we are to take the arithmetic mean of these 2 different scores, and that is, we add 6 plus 7, that is 6 to 7, and divide it by 2. That is the arithmetic mean of these 2 scores. And we are going to have 13 over 2. And 13 divided by 2 is simply 6.5 or 6.5. So the median of this first question now is 6.5. Now let's look at the second question. For the second question, we need to arrange again. We'll have the least 3. The next is 6, another 6, and 7. We have 8, right? We have 9, and we have 10. Let's compare 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Always be sure that the data you're bringing out are the same number as the question. So we can now eliminate from both sides to see the scores that will be at the middle. Strike out, we strike out, we strike out. All right, so we have 7 at the middle. Therefore, the median is equal to 7. For the third question, we do the same. Number 3, we have the least there is 4, followed by 6 twice. Okay, 6, 6, and another 6 again. So we have 7 there. We have 3 8s, right? And we have 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, now we can simply strike them out. We have this way. All right, and we have this score at the middle. Therefore, the median is also 7. Remember, once again, the median is a middle score obtained when the scores are arranged in ascending order or descending order of magnitude. Take note of this. Now let's quickly talk about the mode. The mode is the score that appears most in the distribution. It is the score with the highest frequency or the most recurring score. So any cause that appears more than the other score, that is the mode of that distribution. So we can easily look at the question and estimate what the mode will be. we see that for the first question, we have, just like we've arranged here, we can go back and see 5 appearing 3 times, while the other scores appearing 2 times, 1, 1, 1, 1 time. So 5 appears 3 times, and that makes it the mode of this distribution because it's the highest recurring data here. So the mode is 5. And for number 2, we can simply go back again where we have arranged and see. Number 2, we have here 6 appears 2 times, right? While the other scores appear just one time each. Therefore, the 6 that appears 2 times become the mode of this distribution. Now, the third question, we have 6 appearing 3 times. It also appears 3 times. All right, we have 1, 2, 3 for 6, and then we also have 1, 2, 3 for 8. Therefore, the mode of the distribution 6 and 8. This is called a bimodal distribution. A bimodal distribution. Any distribution that has 2 modes is called a bimodal distribution. All right. Now, we want to calculate the mean of recurring scores. In this case, since the scores in the distribution are just recurrent, we can construct a table to make it easier to do our calculation. So what we need to do is arrange these scores on the table. We have the X, which represents the scores, and we are going to have a tally because the distribution is not arranged on a table. So we have a frequency that is very important. All right, let's quickly do that. We have the list on this distribution is 5. All right, 5. So we can simply put, we have 6 here too. We have 7 there. We have 8 as well. We have 9. We have 10. Right, and we have 11. So the table we need to extend anyway. All right, let's quickly do our counting. We have 7 here, 7. We have 9. We have 6. We have 10. We have 8, 8, 2. We have 9 again. We have 11. We have 8. We have 7, 9, 6, 8, 10, 9, 8. This time we have to cross it. 7, 7, 8, 9, 5, 6, 7, 8, 9, 8, 7, 5, 5, 6. All right. These are the number of times each of these data appears in the distribution given here. So we have here as 3, we have 4, we have 6, we have 8, we have 6 here, 2 and 1. For the mean of a recurring data, we use the formula mean equal to summation fx over summation f. Summation fx over summation f. F is a frequency and x is the score in the distribution. Okay, this simply means we're going to multiply the frequency and the score. So we have 5 times 3, let's have that here, 15. 6 times 4, we have 24. 7 times 6, we have 42. 8 times 8, we have 64. 9 times 6, we have 54. 10 times 2, 20. And 11 times 1, we have 11. Now, summation fx will be equal to, let's calculate that quickly. We have 15 plus 24 plus 42 plus 64 plus 54 plus 20 and plus 11, and we're going to have 230. 230. If we add the frequencies together, we have 3, that is a 3 here, plus 4, plus 6, plus 8, plus 6 again, plus 2, plus 1, and we'll have 30. So summation f is equal to 30. That is the addition of all these. 3, 4, 6, 8, 6, 2, 1. All right. Now let's quickly substitute into this expression. Summation f is equal to 230 over, we have a summation f to be 30. Now we have these to be stricken out, and when we divide 23 by 3, we're going to have 7.6666 to infinity. So we're going to have approximately 7.7 as the mean of this distribution. All right, now let's talk about the median. We simply have the data from here forwarded to this place for the same distribution. We are going to calculate the median now. For us to calculate the median, we can either arrange this in ascending order of magnitude or descending order of magnitude and strike out or eliminate from the either sides, just like we did in the first sets of question. And then for this very one, since is on a table, or because the data is somehow extremely large, we can use the table to determine the median. We can use the table to determine the median. How do we do that? That is what we want to show us here. We know that the total number of frequency of this distribution, or the total number of the scores we have here is 30. So let's determine the cumulative frequency. This is how we determine the cumulative frequency. There is no score before this one. That is going to be 3 plus 0. We have 3. We have 3. We add this 3 to the next frequency. We have 7. 7 to the next frequency. We're going to have 13. 13 to the next frequency. We're going to have 21. 21 to the next frequency. We're going to have 27. 27 to the next frequency. We're going to have 29. And 29 to the next frequency, we're going to have 30. So you can see that the last item on the cumulative frequency column here must always tally with the total number of the data given to us, or the scores given to us, which is 30. All right. Now we need to determine the position of our median here. And to do that, we simply use the formula that is median will be equals to summation f plus 1 over 2. Summation f plus 1 over 2. Now we have our summation f to be equal to 30 then. So we have 30 plus 1 over 2. And that will be equal to 31 over 2. When we divide this, we're going to have 15.5. 15 and a half. So 15.5. And this become the position of our median on this cumulative frequency table. We look at the columns here, the column we have here, where we have this position identified. 15 is more than 13 already, so it's within this row of the data given to us. So the median is going to give 8. You know that the position 15.5 is more than here already, so it is into 21. Therefore, we estimate the median by tracing this particular column to the data given here, the scores given here, and we're going to have 8 as our median. Therefore, the median is equal to 8, and mean we got then is 7.7. All right, let's complete that here. 7.7. Okay, the next target is the mode. The mode of a recurring score. This is how we determine the mode. You know, we forwarded the data we add here to this particular place now. But if we have not done this, you know that for you to find the mode is either you go through all the data and check the one that is most recurrent, or you make a table for your distribution. And from here we can see that the highest recurring data is this, that is 8 appearing 8 times, 7 appears only 6 times, 9 appears 6 times, and the other data less than that, but 8 appears 8 times. Therefore, the mode is simply equal to 8. The median we estimate as 8 as well, and the mean is equal to 7.7. By so doing, we have resolved this question. All right. So we can now talk about the calculating the mean of a recurring score 2. This is the case when the table is already given to us. If the table is already given, all you need to do is to rearrange the table the way that it will suit you. You can have your column for the fx. So we can simply put them in now. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Right. And we have 1, 1, 5, 3, KO. And we have 6, we have 2, 2, 3, and 4. Okay. We are given the mean already. If the mean score of the students is 6, we are required to find the value of K. We are required to find the value of K. All right, let's quickly find our f of x. 1 times 1, we have 1. 2 times 1, we have 2. 3 times 5, 15. 4 times 3, we have 12. 5 times k, we have 5k. 6 times 6, 36. 7 times 2, we have 14. And 8 times 2, we have 16. 9 times 3, 27. And 10 times 4, we have 40. All right. Let's have a summation f first, and this we have a summation fx. Okay, we have 1 plus 1, 2 plus 5, we have 7. 7 plus 3, we have 10. 10 plus 6, 16, plus 2, 18, plus another 2, 20, plus 3, 23, plus 4, 27. And remember, we have k here plus k. So we have 27 plus k. Remember, in our discussion of algebra, you cannot add unlike terms. Unlike terms cannot be added, but we can add the like terms. 27 and k are unlike, so we cannot add them together. All right, let's quickly add up this other side. And remember, you cannot add 5k. So quickly do that on your calculator. I got 163 plus 5k. All right. All right, we recall that the mean is given as summation fx over summation f. So let's quickly substitute. We have the mean is given as 6 already. Summation fx is 163 plus 5k over summation f is 27 plus k. So we make this over 1. Mathematically, we cross multiply now. Cross multiply. Doing this, we're going to have 6 times 27. This should be equal to 162 plus 6 times k. We're going to have 6k. This will be equal to 1 times 163, 163. Then 1 times 5k, we're going to have 5k. When we collect the like terms, we're going to have 6k. This is going to cross the equation sign, and so we're going to have minus 5k equal to 163, which is here before, and this is going to cross to the other side. So we have minus 162. 6k minus 5k is simply equal to k, and 163 minus 162 is 1. Therefore, the k we're looking for is equal to 1. K is equal to 1. Now, we are going to determine the mode, the mean. The mean is already given, which is 6. So the median is the next target. The median. All right. Now that we've gotten the value of k, we can now substitute. Here, k is equal to 1, right? So let's find the cumulative frequency. We have the first one, 1 plus 0, which is 1. Then 1 plus 1, we add it here, we have 2. 2 plus 5, we have 7. 7 plus 3, we have 10. 10 plus 1, we have 11. 11 plus 6, we have 17. 17 plus 2, we have 19. 19 plus 2, we have 21. 21 plus 3, we have 24. And 24 plus 4, we have 28. And remember, the median is given as summation f plus 1 over 2. So we have summation f, which we need to find the summation f first. And remember, summation f here is 27 plus k. You can see 27 plus k, and k is equal to 1 there. Therefore, it is 27 plus 1, which is equal to 28. It must always tally with the last column of the cumulative frequency. So we have 28 now plus this 1 over 2, and that will be equal to 29 over 2. 29 over 2 is equal to 1. We have 8.5. So this is a position of the median. We look at 18.5. 18.5 is already more than 17, so it is within 19. So we now trace this to the score, which gives 7. Therefore, the median is equal to 7. We trace it to the score on this column X. So the value there is 7. Therefore, 7 becomes the median. Now, the mode, we can simply determine the mode. Here, we don't actually need this here anyway. We need here to be equal to 1. Then we look for the data with the highest frequency. 1 is with a frequency of 1, 2 with a frequency of 1, 3 with a frequency of 5, 4 with a frequency of 3, 5 with a frequency of 1, 6 with a frequency of 6, 7 with a frequency of 2, 8 with a frequency of 2, 9 with a frequency of 3, and 10 with a frequency of 4. So the highest occurring data is 6. Therefore, 6 is the mode of this distribution. Please don't forget to subscribe. Don't forget to subscribe. Subscribe to our channel so you'll be informed anytime, any day we upload a new video on this platform. Also share with your friends that they may benefit from this service. Share, like, comment, and don't forget to send the question if you can lay your hand on anyone. If there is anything you want to ask, you can always contact us via this line 09035173164. So we will always be there for you and put you on track. Bless you. Thank you for joining us.